Types of functions / relations and correspondence type. So you're going to be able to identify and differ between the 4 different correspondent types. They are best laid out in an image. There are 4 of them, and we can use a vertical line test and the horizontal line test, which is very similar to the vertical line test. So the vertical line tells us that this guy is a function. The horizontal line tells us that how many it is to that, which will make sense more in a minute. So we do, this one here is a 1 horizontal line test to 1 vertical line test. We can see the colors, horizontal, 1 to 1. This is the first type of correspondence. The second type here is a many to 1 correspondence. So the horizontal line tells us it's a many, and then the vertical line tells us it's a 1. So I like to think many 1, or da, right? Swipe down, like a ninja or something. That's number 2. Number 3. Jesus. Number 3. 1 to many. 1 on the horizontal line to many on the vertical line, and then correspondence type number 4 is a many to many. Alright, so right and then down. So if we have a look at it in table format, if this is a pass and a fail of the vertical line test, this is a pass or a fail of the green horizontal line test. Passing the vertical line test is here and here. So passing the vertical line test means that it is a function, is a fun, and it is a fun. Failing the vertical line test means not fun and not fun. A pass on the VLT and a pass on the HLT means a 1 to 1. What I'm going to do is leave this blank, and I'm going to ask you to stop and fill it in. Is this a 1 to 1, or is this a 1 to many, or is this a many to 1? And what about this guy? Is it a many to 1, a many, and then a 1 to 1, a many to many? So put that into your notes yourself. Quick example: identify the correspondent type and state whether it is a function or not. Our example is the x and y coordinates for when y is equal to x plus 3, x take 1, x take 6. First thing we've got to do is sketch the graph. I'm going to do this quite quickly. See how you go keeping up. X-intercepts, I can see really quickly, are going to be equal to x equals -3, 1, 6. Y-intercepts, I'm going to let x equal to 0, and it's going to be 3 times -1 times -6. So y-intercept is going to be positive 18. We've got 2 negatives. It's a positive cubic, which means it looks like this, and it is a cubic because there's order 3. So if I sketch that graph, it's going to look something like this. Positive 18 there, and that's going to be positive 1, that's going to be positive 6, it's going to be -3. 1, 6. Put our arrows on. I've done a bad sketch because I haven't labeled these axes. So now to do the vertical line test and the horizontal line test. Now obviously we need to pick the right point, because if I do the horizontal line test, here, I'm only going to think it's a 1. Alright? But that's wrong, because obviously at this point here there is a many. Alright, it's many on the horizontal line. If I do the vertical line test, at any point that I do the vertical line test, I'm going to only ever have as a 1. So I should have done it first. I should have gone 1 to many. Right? So we can state 1, oops, it should be in blue, 1 to many correspondence type. Is it a function? No. Yes it is. Yes it is a function, because it passes the vertical line test. Yes is a function. Come on, use good grammar, Jesse. Christ. Yes, it is a function. 1 to many. 1 to many correspondence. Cool. I'm not going to define those correspondence types, but make sure you've got this down in your book, and make sure you fill this in. Adios.